We're going to go through three new types of graphs, but the first thing we would like to understand will be how the shape looks like alongside the equation that it comes with. Okay, so let's start with this thing called an ellipse. For an ellipse, the shape looks like it's an oval shape. What we want to understand is, for this oval shape, how do we find these two things? One of them is the center. The other one is, can we try to observe what will be the distance from the center to the sides, which is the width, and also the height of your ellipse. So this can be observed from the equation. Let's run through the equation. For this equation, the right-hand side of this equation is always 1. We will force it to be 1 whenever we get an equation like this. You're going to see two fractions on the left. One of them has x, the other one has y. In order to get the center of the ellipse, it will be done through, you let the numerators be 0. So if I let the numerators be 0, the center of my ellipse will be AB. For those of you who recall the equation of circles, it's similar, where the squared part, if you let it be 0, you can get center of a circle. Okay, later I will draw the relation with a circle. The other will be the value below your x and y are important. The one that is below x will give you the width of your ellipse or the x distance. Think of this as an x distance. So to get an x distance, you get the value below x, which will give me h. To get the y distance is the value below y, for which then you have k. So one last important thing that you need to know is, for this equation, we can see that the highest degree of both x and y are 2. And at the same time, they will take on the same signs. So because they have the same sign, meaning both are pluses, I should expect in the expansion, the x squared and y squared take on the same sign. Because sometimes they give you in this kind of expanded form, which I call it the non-standard form. In a non-standard form, to observe that it's an ellipse, we will see this portion where you have both positive x squared, positive y squared. They have the same sign, that's why it's an ellipse. Then we go to the second type of graph. But let's observe the equation first. You are going to see that the right-hand side looks exactly the same. 1. Even in the middle, almost entirely the same, except at one position. There will be a negative sign appearing either at the x, or you will see the negative sign appearing at the y. It sketches out a graph that is slightly different. This kind of graph that has asymptotes is called a hyperbola. It is different from the one on the top. The ellipse does not have any asymptote. Only the hyperbola has asymptote. So let's get the orientation first. One of them is top down, one of them is left right. In order to know which is which, you look at who is positive. This is positive for y, this is positive for x. If the positive is at y squared, then we think of the graph as its top and bottom oriented, or we see as it is drawn along the y-axis. There is a name for this graph that is drawn along the y-axis. We call this a vertical hyperbola. The second equation is with positive x squared. It is similar. Positive x squared will be a graph drawn along the x-axis. So instead of vertical, we call this a horizontal hyperbola. We first learn how to get the center first. Center is now thought of as the intersection of the asymptotes. These are the center in red. So center is given by same thing, you let the numerators be equals to 0. So therefore this is your AB. After you set numerators to be 0, you get the center. The second equation similar, that's your center at AB. Set numerators to be 0. There is this point that is the turning point on that top graph, but in hyperbolas, we call this the vertex of the hyperbola. So these 2 points are the vertex. In the second graph, these 2 points are the vertex. Vertex need not be on the axis, it depends on where your center is located. But the important distance we want to know for the hyperbola is the distance between the vertex to the center. Distance between vertex to the center. But because of the orientation changing, each of them is a different value that we will read off from the graph. For the one on top, this is a vertical distance, a y distance. A y distance, you read the value below y. So that is k. If it's a y distance, read the value below y. Second graph here, this value is a value below x. So this will read as h. So for this two, I've covered that the asymptotes will be intersecting at AB, the center. You will still see degree 2 on both x squared and y squared, but because of the minus sign appearing, I expect x squared and y squared to take on opposite signs. They won't have the same sign. And the last thing is on asymptotes. There were two asymptotes. How do we find that equation? So for this asymptotes, I want you to make the observation easier for us to see from there. You're going to see that this 1 doesn't appear in the equation of the asymptotes. Second, all the squares don't appear. It's like you have taken square root. And because you have taken square root, there is a plus minus appearing as well. Okay, so can we understand the logic first? How come the 1 disappears? It's because when we try to observe asymptotes, maybe we look at this position. For asymptotes, it's because the graph goes very, very close to that position. So what happens when x tends to infinity? So this black part is optional. It's more for understanding purposes. When x tends to infinity, your y will also tend to infinity. Which means these two values are both very large. And that makes the value 1 on the right side becomes insignificant. Therefore, what we should have is this value is like becoming 0. It's insignificant compared to this 2. And I will have x minus a squared is approximately equals to y minus b squared over k squared. Since 1 is negligible now, these two fractions will be approximately equal. So you remove the squares, therefore there will be a plus minus, there's like a square root. Okay, but not important to know this, they will not test this, but they will test for the understanding of how to write down the asymptote equation. Practically, I'm going to do it this way. We will think of it as you remove the 1. So the value 1 is gone. Number 2, remove squares. And number 3, insert a plus minus. When I put the plus minus, usually we put it on the side with x. And the reason is because we will be making y the subject. Your equations or graphs are always with y the subject. Remember, only hyperbola will have asymptotes. Ellipse does not have.